Okay, dear students, welcome to online tuition. We're going to discuss about the first topic of Form 3, which is application of vector. And in this presentation, we're going to discuss about scalar and vector quantities. But before discussing about scalar and vector quantities, let us now see about physical quantities. When you were in Form 1, you were studying about physical quantities. What are physical quantities? Physical quantities are any characteristics that can be measured by instrument. For example, we can measure weight by using spring balance. Also, we can measure mass by using beam balance. We have two types of physical quantities. We have fundamental physical quantities and the derived physical quantities. What are fundamental physical quantities? Fundamental physical quantities, these are physical quantities that cannot be obtained from any other simple quantities. For example, we have mass, time, length, temperature, electric current, we have amount of substance, and we have luminous intensity. But from fundamental physical quantities, we have get another quantities which are basic fundamental physical quantities, which are mass, time, and the length. So what are derived physical quantities? Derived physical quantities are those physical quantities which are obtained from basic fundamental physical quantities. For example, we have velocity, we have acceleration, and so on. But physical quantities can be divided into two. We have scalar quantities and the vector quantities. What are scalar quantities? Scalar quantities are those physical quantities which have only magnitude. And vector quantities, these are physical quantities which have both magnitude and the direction. So when we are talking about magnitude and direction, what is magnitude? Magnitude is a size of an object. For example, when we're talking about 20 kilometers. 20 kilometers, this is the size which emphasizes that the distance from one point to another, it is 20 kilometers. But when we are talking about direction, this means that we are talking about the angle in which an object is moving. Okay, let us now see examples of vector quantities in the scalar quantities. This is force. Force is a pull or push. So if you want to pull or push, you must pull or push in a specific direction. We have displacement. Displacement is a distance covered in a specific direction. We have velocity. Velocity is the rate of change of displacement. So because displacement has got direction, also velocity has got direction. We have momentum. Momentum is a product of mass and its velocity. So when we're talking about velocity, this means that we are going to discuss about direction. Okay, we have acceleration. Acceleration is the rate of change of velocity. So acceleration has got magnitude and the direction. Okay, we have scalar quantities. For example, we have time, distance, temperature, energy, and speed. These physical quantities have got no direction. For example, when we're talking about 20 minutes, 20 minutes shows the interval of time. Are we together? Okay, according to our topic, it is application of vectors. So we're going to discuss much about vector quantities. Vector quantities are represented by using a diagram which is known as vector diagram. And vector diagram has got two parts. We have head and the tail. Okay, let you see here. This is a vector diagram. This diagram used to represent a vector quantity. As I said that it must have a tail and a head. As you can see that a head have got a halo. Are we together? This halo used to present the direction. And the distance from here up to here, or a length, used to represent what? A magnitude. we have two types of vectors. We have equal vectors and the opposite vectors. Equal vectors are those vectors which have the same magnitude and direction. As you can see that the length of vector A is equal to the length of vector B, but these vectors are in the same direction. But also we have opposite vectors. Opposite vectors are those vectors which have the same magnitude but are in opposite direction. For example, this is vector A. The length from vector A up to B, the length of vector A up to here is equal to the length of vector B from here to here, but are in opposite direction. So vector A is equal to negative vector B. Okay, dear students, thank you.